Welcome to Chapter 21, Part 3. So we're starting with example 8, and we're looking at 500 milligrams is our order. The strength, we have 100 milligrams in the denominator for every 1 ml. So our milligrams cancel. So we're going to be needing 5, so we have 5 mLs. After adding the ampicillin to the volume control chamber, how many mLs of fluid will you then add to the volume control chamber? Well, the volume control chamber goes up to 40. So we have 5 mLs of medicine. So then we're going to add up 5, so we're basically saying 40 minus the 5. We're going to add 35 mLs to the VCC. We go back to a safe dose range question. So I'm looking at 2.2 as my low, 2.2 milligrams per kilogram times day. And we're talking about a child who weighs 45 kilograms. So that's a max of 99 milligrams per day. I'm sorry, a minimum. We're looking at a max of 4.4 milligrams per kilogram times day. Child still weighs 45 kilograms over 1, and that gives us 198 milligrams per day. We're looking at 100 milligrams, which is in between 99 and 198. So yes, it's safe. At what rate will we set our pump? So we're looking at we need 100 milligram vial must be, so 100 milligrams is the dose that they want. The 100 milligrams is mixed with 10 mLs. So if we have 10 mLs, that will give us our 100 milligrams. So I'm going to take my 10 mLs, add it to my 100 mLs, and they want it over 1 hour. So my pump setting will be 110 milliliters per hour. In example 10, now we're doing a maintenance, a fluid maintenance for a child. So our fluid maintenance goes by this schedule right here. For the first 10 kilograms of their body weight, we give them 100 milliliters for every kilogram. For the next 10 kilograms of body weight, we give them 50 milligrams per kilogram. And then for anything above, we're going to give them 20. So we're breaking their body weight down into 10, 10, and then anything above. So here they have 35, so I'm going to break it down into 10 kilograms, 10 kilograms. So that's 20 kilograms. They actually weigh 35, so I have 15 kilograms. So that totals their 35 kilograms. For the first 10, we give them 100 mLs. I'm going to times that by 100 mLs per kilograms. So that gives me 1,000 mLs. For the next, I give them 50 mLs, and for the following, I give them 20. So 50 times 10 is 500 milliliters, and 20 times 15 gives me 300 mLs. So that's 1,800 mLs given over 24 hours. So I'm going to take my 1800 mLs divided by 24, and I get my pump setting at 75 mLs per hour. So here the child weighs 33 pounds. So 33 divided by 2.2, they actually weigh 15 kilograms. So remember, we break it up, 10 kilograms and then 5 kilograms. So that gives us their total weight of 15 kilograms. Now for the first 10, they get 100 mLs per kilogram. And then they get 50 mLs for the next. So this is going to be 1,000 mLs. 50 times 5 gives me 250 mLs. So 1,250 mLs is the pediatric fluid maintenance for this child. Now they're not asking us what the pump setting is. It's just determine the normal 24-hour fluid replacement. So they would need 1,250 mLs for their fluid replacement. In example 12, they're looking for a half dose at 35 kilograms. Now we did that in example 10. So in example 10, we got 1,800 mLs. So 1,800 mLs and a half dose would give us 900 mLs for this child if we wanted a half pediatric fluid maintenance dose. And last, in example 13, we're starting with crooked paper, which is not good. All right, let's see. So here we're starting with our 100 milligrams of the drug, because that's what's ordered. Our strength is 10 milligrams per ml. So I'm going to need 10 mLs. So we need 10 mL. So and if the recommended concentration is 5 milligrams per 1 ml, how would you then dilute the medication in the VCC? Well, 10 mLs have 100 milligrams in them. They want a 5-to-1 ratio, so I would add 10 mLs to the VCC. That would give me, I would have 100 milligrams from this, and I would have 20 mLs. And if I reduce that, I get 1 to 5. So that's my 1 to 5 ratio. 1 ml to 5 milligrams. So here we have 400 milligrams. The strength is 160 milligrams per 5 ml, and they want it in teaspoons. So remember, 1 teaspoon is 5 mLs. mLs cancel, milligrams cancel. I'm left with teaspoons, which is what I need. 5s cancel, So I really have 400 divided by 160. And I get 2½ teaspoons. Here we're starting with, excuse me, 20 milligrams per kilogram. The child weighs 42 kilograms. When we multiply that together, we get 840 milligrams. Our units of kilograms cancel out, and I'm left with just milligrams. Alrighty, so here we have an IV bolus of 1% lidocaine. So first we have to figure out the strength of the lidocaine. So let's see. I'm going to give 0.1 milligram per kilogram. You know we have 40 kilograms. And now my strength will go right here. 1%, remember 1% as a decimal is 0.01, which is the same thing as 1/100. Remember, this is in grams and this is in mLs. So we actually have 1 gram over 100 milliliters. I'm going to change this to milligrams, so I have 1,000 milligrams over 100 milliliters. And when I simplify that down, I get 10 milligrams per ml. 10 milligrams per 1 ml. And now I have my setup. How many mLs will you give? My answer is going to be in mLs. So I'm going to take my 0.1 times 4. Oh, sorry. That was 0.1 times 40 divided by 10. And I get 0.4 mLs. And the very last problem, I have 8 milligrams per kilogram times 18 kilograms over 1 times my strength, 5 ml over 100 milligrams, kilograms, wait, that should have been, yeah, K there. So 8 times 18 times 5 divided by 100 will give me 7.2 mLs. Alrighty, hope you liked it. Thanks.